je veux commencer par dire que je suis bien heureuse d'être ici en France, en Montpellier. C'est la première fois pour moi. Et ça fait, 15 ans que je ne parle pas beaucoup de français. Et même, clairement, j'ai un accent un peu québécois. So I'm quickly going to switch to English. I also wanted to say that I really appreciate the invitation from Cesab and supported by the Bertarelli Foundation to be here. There's Al Gore quoted an African proverb that said, if you want to go fast, vas-y toute seule, but if you want to go far, il faut le faire ensemble. So it's really, to have an opportunity like this to come to Montpellier, work with a wonderful team has been fantastic. So I'm going to talk about the status of ocean wildlife. So basically, we probably all know that our oceans are in serious trouble. How many people in this room were born after 1996? After 1996, right? So not very many. Well, sucks for you. You've never seen oceans where fish are thriving. We hit peak fish in 1996, and it's been going downhill at approximately 1 billion kilograms per year ever since. That has serious implications for our economies. It has serious implications from food security, as we've just heard from Anna, in places where people are so highly dependent on fish. I show this picture in Australia, where I now live, because it's not just about commercial fishing, it's also about recreational fishers that take a rather large amount of fish, particularly the big old fat females, out of our oceans, and that too is a problem. And work we just published last year shows that fish no longer have anywhere to hide. Basically, we've expanded from covering about 40% of the globe with our fishing activities in the 1950s to about 95%. So there are literally very few areas that we no longer exploit. And that means that we can't prop up our fish catches by going further afield. And if you look at iconic species, what we know from the IUCN Red List is that we're just seeing rapid declines in some of the most iconic predatory species in our oceans. Anywhere from, basically for some species of turtles, we've got about 5% left. And even yellowfin tunas are down by about 60%. Now, I like to bring up Australia because everybody, Australia loves to tell the world how well managed its fisheries are. And we're doing a great job. And we actually should be doing a great job because we don't have a lot of people. We don't have a high reliance on fish for food. And we've got stable government and a reasonable amount of money. However, in the last decade, we've lost 30% of our big fish in Australia. 20% of the fish stocks that are managed by the Australian authorities are overfished, or we don't have any idea. And for our sharks, where Australia has a rather terrible program of thinking it can protect swimmers by putting nets out, we've lost up to 90% of some of our major shark species in the last 50 years since we started meshing and drumline programs. And this is all peer-reviewed science that's been published. So we're not doing a great job even in Australia. So that's the bad news. I like to always try and be optimistic, and the challenge that we now have is that there's the opportunity we have is that there's increasing interest in large marine parks. And by that, I don't mean the Great Barrier Reef hugging the coast or Ningaloo Marine Park hugging the coast, but actually taking big chunks of blue water, open ocean environments and protecting them. And we've done that, for instance, in the British Indian Ocean Territory, off of Hawaii, and there are a few examples around the world. Now, I've put up, this is a map that you don't normally see. Normally, when you see a map of all the global marine parks around the world, you've got lots of different colors because they show IUCN 3, 4, 6, etc. And I just like to make the comment, I don't know how to say this in French, but partial protection doesn't work. When did your sex ed teacher ever tell you it would? Ça marche en français? Peut-être? Okay, so the reason I like to focus on the IUCN 1 and 2 is because these are the areas that we know work in terms of generating conservation benefits. Challenge is we don't know actually a lot about open ocean pelagic ecosystems. Most of our information comes from fishing, dead fish in a net on the back of a trawler, and that's all we know. For coastal marine parks, we know that they work. If you close an area to fishing, you get higher diversity, more fish, and indeed, bigger fish, your biomass can increase by up to 500%. So the challenge that I wanted to take on was to say, does it work in the open ocean? If we protect areas where we have no fishing, do we get more fish? Are they bigger? And is there greater diversity? And we had no data to test this question in 2010, when the Biot Marine Park was the world's biggest fully no-take marine park that came in. So what did we do? Oh, and this is my point. Less than 3% of research papers are on pelagic marine protection, right, with 97% being on coastal protection. So I basically put 2 GoPros on a stick with a float, and we dropped these in the ocean. And what's the amazing thing is, just like baited remote underwater video systems in coastal areas, we get a video record that records the diversity, the abundance, and the biomass of the fish in the Big Blue. I own more GoPros than anybody else in the Southern Hemisphere. This is our main tool. The reason I point this out is we could not do this work without the development of automation, miniaturization, and so on. So technology is our friend for understanding open ocean systems. We've also made it cheap, small, and easy, so we can basically deploy this method off of small boats, big ugly boats, and really nice big flashy boats. So this is what it looks like. So my main point here is that we used to basically just learn about fish by catching them. We've developed this little rig that allows us to learn about open oceans without killing fish, except for the bait. They're obviously dead and not very happy. And this gives you an idea of looking down on a rig and the various species. Because the method is cheap and easy and lightweight and basically really easy, we've been able to go all around the world, and that's starting to give us a global picture of what pelagic ecosystems look like. And this is the work that we've been doing along the West Australian coast. It's not glamorous. It really isn't. Small boats, rough seas. This is my postdoc, Phil Boucher, who always smiled, even in the worst conditions. Basically, the rig goes over the back of the boat, and this is what the pelagic environment looks like. Occasionally, and this is part of the challenge, and it's where machine learning and AI is going to become really important, is being able to pull out the data from these large, lengthy periods of blue. So this really just gives you an idea of what we get, including the odd curious whale. And what I really enjoy about or appreciate about this data is we're not just seeing the predators or the commercially important species, we're seeing everything down to the prey on which they depend and some cute behavior. The other thing that's, I think, important about the videos is if you tell people, oh, we need to protect the coral reef, they say, yes, I've snorkeled on it, I love it. But if you tell people that they have to protect the Big Blue, what do they know about it? So the other advantage of using video-based techniques is we can engage people in understanding what 75% of our planet looks like. So I'm not David Attenborough, but I'm working on it. Anyway, we'll stop that. That's enough of that. Oh, we get birds too. And we had a penguin. We had a penguin. Couldn't believe it. The penguin went swimming right across. N equals 1. So just to reiterate, these are all the places that we've worked around the world. So this is giving us an opportunity to better understand pelagic ecology on a global scale. And it can be fun. I have no idea how my PhD student smuggled his surfboard on the boat going to Tristan da Cunha. So this is what we do at a given location. So we deploy our rigs in lines of 5. So imagine like a long line gear. So you've got 5 rigs with 200 meters of line between them, and they drift. So each of those rectangles is a drift box for one string of rigs. And those are 2 surveys that we've done. And we've designed it to be inside and outside the marine park off the coast of Western Australia. So we go out in the field, bring back the video, and the 3 main things that we do are identify, then we count, that's 165 scads, Decapterus, and then we measure because our rigs are stereo. And if anybody ever wants to use baited remote underwater videos, do not use single cameras. You must use stereo, because without distance, you don't have your sampling unit, and you can't get size, and size matters. Right, so what have we done? Since 2014, we've collected data on 74 families, nearly 200 taxa. We've identified, counted, and measured over 100,000 fish. And they range from small 1 centimeter juveniles all the way up to over 10-meter humpback whales. Rarity matters in the ocean, and we're going to have to think about how we deal with this, because 16% of our taxa we only ever saw once. One animal, one place, once, and that's it. So that's an interesting statistical challenge as well. So I'm now going to go into what we've learned. And these little guys, short fin makos, they're juveniles because they've got a black nose. As they mature, the black spot goes away. So we don't know a lot about these guys, and these are endangered on the IUCN Red List. But with dropping our cameras, what we found is that we've been able to identify nursery areas for these critically, well, not critically, but endangered species. So all the gray dots are where we sampled and never saw short fin mako. All the dark blue dots are where we saw adults. And the turquoise dots are where we saw juveniles. We never ever saw juvenile, neonate, young of the month, young of the year, anywhere but that western corner of Western Australia, where we saw them consistently. So this starts to give us information on what areas do we need to protect. And indeed, the interesting thing about these locations is where we saw juveniles, we had small fish and high abundance of fish compared to where we saw the adults. So there's something different about these places and the structure of the assemblages that are supporting these animals. So my next question, excuse the mess. I get from fisheries scientists all the time, oh, you can't have marine parks in the open ocean because fish move around, right? So my response is, well, then catch them over there, right? Ça marche. So they always say these systems aren't stable. Where would you put a marine park? How would you have static boundaries? So we took up that challenge and we went to Perth Canyon, which is just west of where I live in Perth. It's the largest undersea canyon in Australia, and it's bigger than the Grand Canyon in the US. It's huge. And we sampled at the head of the canyon for across 7 years and 2 seasons. So that's the mess of all those lines. So what did we find? It is indeed stable. You get pretty much the same taxonomic richness every year, the same abundance every year by season, and don't get distracted by the error bars. When we did a power analysis, you would be able to detect change. There was one exception in this. In 2018, in the autumn, all of a sudden there were no fish. Now that happens to coincide with when the government announced that it was about to decide what it was going to do and whether it was going to close the area to fishing. So guess what happened? All the boats went out, right? Get in fast before it's closed. And we've got good data on fishing effort to support that inference. So the other thing we've been doing is going up and down the coast, and aren't clever PhD students wonderful when they can create graphics like that? So those are snapshots of the fauna that we saw up and down the coast. We collected lots of data. We had all these covariates, environmental covariates, bathymetry, and so on. And we found that the best predictor of abundance was humans. More humans, fewer fish. What's scary about this is supposed to be a relatively pristine part of the world. Small population. Depth didn't matter. Temperature didn't matter. The only thing that mattered was the size of the population nearest to the area that we were sampling. And we were able to explain between 37 and 60% of the variation in diversity, abundance, and biomass based on us. So again, these are the types of arguments that we need to take to policymakers. So just by saying as well, if I said, hey, I've got 7 taxa, 7 species in an area, we don't know whether that's a lot or a few. So by going all around the world, we're also being able to start defining baselines and an understanding of what these places look like in the open ocean apart from fishing data. So that's just by way of saying we can actually look at patterns. OTs are the overseas territories, so that's like Ascension, the Australian sites, and so on. So we know, how am I doing for time? Yeah, I'm going too quick at that. So I guess I just want to leave you with an advertisement. We actually know what to do. right? There's 40 years of research on the importance of marine protected areas for ocean conservation, whether it's coastal and now offshore. We know that we need our protected areas to be no-take. We know that we need them to be large, well-enforced, and so on. So I think, in a sense, what we're trying to do is provide the data to drive policymakers to make better decisions, even though we know what the answer is. So this is on the Great Barrier Reef, near the at the Marine Park, I think in the 60s, based on the swimsuit and the hair. And my point with this is, every time I show this video, which was on the national broadcaster in Australia, people sort of go, what were they thinking? You know, how is that ever cool that you go down the beach and you lasso a turtle and ride on it? But that was completely reasonable behavior in the 60s. And so I think part of our challenge is driving that cultural change about how we interact with the ocean. It is not sufficient to say going out and dragging big fish. I can't remember if I left it in. Oh, no. Dragging big fish out of the water for sport is a reasonable use of that wildlife. And until we make those sorts of decisions, and some of you will have seen the paper that just came out about what we need to do because we're already at tipping points for the planet, right? And a big one is about how we think about protein. So I don't want to, 30 years from now, kids looking back on what we do at the ocean and thinking we were as stupid as this. And that's what I'll leave you with. So to finish up, as I said at the beginning, it takes a team. I've got a wonderful team that spends more time in the field than I get to. It sucks. So can't do it alone. It's a huge data set. I'm looking forward to the collaboration so that we can actually start translating this massive amount of data that we have into better outcomes. And you can't do it without huge support from those who believe that science matters. So thank you for that, and I'm happy to prendre des questions.